The free coffee, the free tea, come on.
Yes, we are good.
Okay. Hi everyone. So there's a new session at Azure Qatar Community. I'm Hamza, the organizer at Azure Qatar Community, working with my colleague Fateh. He's a Microsoft employee. And so how are you all? Okay, few of you, but how are you? Okay. So the Azure Qatar Community is the community, tech community that comes up with every week with new topic of session, whether it's security, DevOps, cloud, anything related to Microsoft. And today we have Zoheb. Has a 12 years of experience in security and SaaS platforms, and he's also working with Microsoft for more than 9 years, right, in the field of security and stuff like that. Okay. So the today topic is cloud authentication, phishing resistant with Microsoft, right?
Yeah.
Okay. So I'll give the platform to the Zoheb.
Perfect. Hi everyone, thanks for joining. Much lower audience, but happy for you guys to join. Before we start, I just want to know how many of you know about Passkeys at all? Yeah. So you're using Passkeys. So that's the second question. Are you using Passkey in your organization? Yeah. Great.
Yes.
Final question before we go into the topic. Are you using Microsoft Passkeys at all in your organization? Okay. All right. So today, so first of all, before I proceed, let me give you a brief introduction about myself. I've been with Microsoft in different roles and different locations. I'm originally from India. I started my career as a support engineer. Okay, so the image there and right now it looks quite different because I think this image is like 6 years old. But I started as a support engineer. I was working into the Federation Services, Directory Services team. Couple of teams I work in support. Then I got an opportunity into Malaysia. Then I joined, so I was in HP Malaysia. Then I joined Microsoft. In Malaysia, I was working as a field engineer. And then since last 5 years, I am working as a cloud solution architect in Qatar. So presently, I'm mainly working with some of our strategic customers, what we call it as mission critical customers in Middle East and Africa region and wider EMEA region as well. I specialize in identity security, and over the years, I've developed some skills around Azure as well. Today, we are going to talk about the same thing, okay? So you know, when I introduce myself, I think one of the things is I like to call myself as a problem solver, and cloud solution architect is the title which Microsoft gives, right? But at heart, like throughout my tenure, I've been solving problems, and I enjoy that. So in today's session, and the topic also is something which is very useful because this helps me solve many problems at customer, which is about passkeys. So we'll be talking about briefly on phishing. I will give you one of the ways phishing attacks generally happen in the organization. Then we will go into a little bit of authentication history. By authentication history as to how authentication has evolved from passwords to authenticator and now to passkey. And then we'll talk about what and how passkeys work and why is it secure. And we'll talk about some of the properties of it, some benefits of it, and we'll also dive into some demo sessions wherein I'll show you how to enroll. So there will be two types of demo I will give you. How does the registration work and how does the sign-in experience work, okay? And I think after the session, we have some giveaways. So please pay attention to this. So there are some giveaways which I will be giving. So whatever we are going to talk about, I'm going to ask you some questions based on that as well, okay? Father, before we start, anything I'm missing?
No, we are good. We're going to finish at 8.
Yeah.
Okay.
Yeah, so I will, yeah, I know Fateh is reminding me of time, so we'll try to finish in 90 minutes. Though, you know, the presentation seems quite long, but I will try to be mindful of time. Now, what is phishing? So this is, so for those who don't know, I'm just going to lay down a basic. Phishing is an attack designated to deceive people into sharing sensitive information. This is particularly difficult from an organization perspective because, okay, you can imagine, like, you know, when you're you get phished and you share some personal information, but from an organization perspective, you're sharing organizational data, which is very difficult. So this is just a number which I'm sharing here. 30,720 malicious domain were generated every 3 days as per the Microsoft Digital Defense Report in 2021. I was looking at the Digital Defense Report of 2024 also. This specific number is not there, but you can imagine this number must have grown. But just understand 30,720 malicious domain generated in 3 days. You can imagine how many phishings would have happened through this. Okay. Now, this is another data which is related to how most identity attacks still use passwords. So this is the Microsoft Digital Defense Report in 2024. So last year's report. We have more than 99% of these attacks coming from things like password reuse, weak passwords, and we are seeing even multi-factor authentication. Okay, so now the technology is getting advanced, so the attacker is also getting advanced, right? So we are seeing even MFAs are being targeted. Okay, now generally the way it works is, if I'm an attacker, I would target. My targets would be like, if there are targets which are expensive, by expensive I mean which are difficult, these are expensive for the attacker. If it's easy, this is less expensive. So the kind of technology you adapt, it depends on the chances of you getting attacked. Not saying that, with Authenticator you might not get attacked. You can still get attacked with Authenticator, and we are seeing that. So we are seeing MFA based attacks. We are seeing SIM hijacking. We are seeing these things which are in a way affecting our multi-factor authentication also. So what we were thinking a couple of years back, that if we have MFA, I'm bulletproof. It's not the case. I will also show you how attackers are utilizing MFA in the next slide. So this is an example of adversary in the middle attack. Okay, so in this attack, basically what is happening is, first, the user is visiting a phishing website. Okay. Now, in this case, the attacker has come into your environment. It has built an identical website. Okay. So, like right now, what you see, this website, the attacker has built a website like, let's say, Microsoft.com. Okay. Now, a website like Microsoft.com is built, which is identical. The domain name is also identical. Okay, you can't differentiate. There's a small apostrophe at the top of I. It's very difficult to differentiate from a user perspective. So what attacker is doing is, they are trying to get into the environment. So as a first step, what they are doing is, the user is logging into the malicious website. Okay, through phishing, through SMS, through various mechanisms, this link can be there. Okay. Now, when the user is logging in, the other thing which is happening is, the attacker is simultaneously logging in to the genuine website. So here you can see, this is the malicious website, and the target website is on the right. So the user is never going to the actual website. User is on the malicious website, which is here, and where the attacker himself is going or herself is going is on the target website. Now, the second thing which happens is, naturally, if you go on a website, let's say it's login.microsoft.com, you are going to enter credentials, right? So you will be entering password, and it all looks legitimate. You are entering password. The attacker is also entering password on the actual website. Okay. Now, naturally, after you enter password, you get a MFA prompt, right? This is something which happens so often. So we are being prompted for MFA, and so it's the website which prompts us for MFA, right? Because that's a requirement. In turn, the phishing website is also going to prompt you for MFA. Okay. Now, the user is going to look at the phone. So generally authenticator would have two ways. One is to approve, right, that it's a genuine attempt. The second is going to be like you are going to enter a code, right? It's going to display a code on the screen and you're going to enter. So the attacker is going to manipulate this exact same thing. So, and then the user is able to access, user is rejected. It will say that, sign in attempt failed. User doesn't even know that it's phished at this point of time. And user would never know. But the attacker has got the token and has pretty much access. Now, this might have been your exchange online. This might have been something else, something internal website. It can be anything, right? So what I'm trying to establish is this way the attacker was able to penetrate your environment, get the token, and once it has the token, it can do a lot of things. I'm not even getting off what all it can do once it gets into the environment, because we are trying to reduce the first step here, okay? And I'll talk about it, how does this work, and what are some of the prevention mechanisms. But let's try and understand a little bit of the history, okay? So the first things which came was password, okay? So here it talks about some of the good things, some of the bad things. The good thing is passwords are easy, okay? Easy to remember. We can just type it and that's it. So it's quite straightforward, easy. Users are used to it. Since we are using internet, we are using passwords, right? So we are not troubled in such way. Now the problem with passwords is, generally as users, what we tend to do is, when we are entering passwords, we keep the same passwords across all websites, okay? So hypothetically, if you kept a password for some website and you kept the password same for your corporate account, if that website is compromised, it leads to your compromise as well. I'm not even talking about some of the other issues it can have. Like it talks about can be stolen, often leaked in data breaches, users forgets them. So there are a lot of scenarios like this. Now, the second thing which came was the OTPs, one-time codes which were sent by SMS or emails. Now they were one step ahead, but since they added another layer, one was it was cumbersome from a user perspective because users had to type in, find the SMS and do that. But we have seen issues related to SMS hijacking. So in this, SMS is hijacked, emails are interrupted if you're receiving OTPs through email. So this is again a problem which we have seen. The other option was FIDO V1. Okay, this is great, but one of the main issue, and I'll jump on to some of the other things. One of the main issues with this was user had to always carry the device. Okay, and if at all we forget the device, then it's a problem, right? I still have customers who use this. This is something which is from a security perspective good as well, because this works on PKI, public key infrastructure, wherein they have a key pair and they work quite well together. But it's difficult to scale. If you want to scale it for the entire organization, this is difficult to scale. Now this type is the Authenticator app. This is something which we are using a lot today. I have most of my customers using this, okay? Now, so this is not just with Microsoft. This is with across many, like Google have Authenticator, and I'm sure there are other authenticators as well present. Now, this is great, but the problem is they are MFA fatigued. By fatigued, I mean users are used to entering yes for approval. And when you are used to entering yes, then you tend to approve, right? The scenario which I talked about, this is exactly talking about that scenario, okay? Now, I'll show you a quick, I want to show you a quick snap of Microsoft Entra portal, okay? So that I want to talk about the authentication strength, if you can see it. So I'm in the Entra portal and here we have three types of authentication strengths under security, okay? So there is a strength which is called multi-factor authentication. Then we have passwordless MFA and then we have also written phishing-resistant MFA. Now, naturally, you can see that passwordless MFA and phishing-resistant MFA are categorized differently, right? Now, here you can see, this is my passwordless MFA screen. This has 4 options: Windows Hello for Business, Passkey, certificate-based authentication, and Microsoft Authenticator. So these are the 4 options which Microsoft gives from a passwordless MFA perspective. But we also have something called as phishing resistance MFA. And here you can see one of the options has gone, right? Which is that option? So you can see the authenticator is not there. Okay, so we have got Windows Hello for Business, we have got Passkeys 502 and certificate-based authentication. So this is how at Entra we are differentiating. Okay, passwordless MFA, phishing resistance MFA. This is how we are differentiating. So in other words, we are not considering Authenticator, Microsoft Authenticator as phishing resistance. Okay, so for phishing resistance, we are pushing for passkeys. Yeah, you have a question?
Yeah. So sometimes when you use Authenticator, you have to put in a number and your fingerprint, right?
Yes, yes.
How can the fingerprint be like forged?
Yeah.
Or if you only use the fingerprint, can it be phished as well? Or?
Yes, yes. So see, the problem is not with what you're entering and how you're using fingerprint. The attack which I talked about, you are assuming you're getting phished, wherein the website you're accessing and giving information is not the actual website. So the attacker is manipulating MFA, and in the backend they are accessing the website. So it gives you similar prompt, you enter it, and that's how you get phished. So sure, your biometric is genuine and you need biometrics, but the problem is not with biometrics. The problem is with phishing and URL identification. This is the real problem.
Can this be revealed maybe using location? So
yes. Actually, with prompt we also give location, right? If you're not looking into that, then you can. If you're careful into that, then you can definitely be vigilant about this. Yes, but let's say you don't look at location, then you can get. And there's one more reason: the identification of the URL. So login.microsoft.com and login.microsoft.com there's an apostrophe on the I. So because you're not able to detect that, this is what is causing. So there are 2 reasons, right? And I'm going to go back to my presentation now. So this is the problem with authenticators, which we are trying to solve. So in a simple word, what he tried to say is right, but the adversary in the middle attack, this is what I tried to show. Even MFA can be fatigued, or even MFA can be compromised using this kind of mechanism. And the main problem is, when you are entering password, you are not verifying the URL, or the system is not able to verify the URL. Let me put it this way. Okay. Now we are all from the IT background. Let's say we are all very well aware, but there are a lot of users who are not so well aware. Okay. The other aspect I'll tell you, like, let's say you get a call from Microsoft Help Desk. You're a Microsoft employee, you get a call from Microsoft Help Desk and they tell you, I'm trying to verify your system. There has been an attack, so we are just trying to verify, give me the OTP. And there's a possibility user might get phished. User awareness, right? So this is again a problem. So we are trying to eliminate user behavioral level problem. So you are not dependent on user to verify it. When you are dependent, fine, like out of 100, maybe 95 people would not fall for it, but maybe 5, maybe 2, maybe 3, maybe 1 person will fall for it. And even if 1 person does, then it's a big problem. Now,
I have a question.
yeah.
Like you were talking about the man in the middle attack in the MFA, right? How does the man in the middle, he's using his own website, right?
Yeah.
So when the OTP is generated, or like a number is generated in the genuine website,
Yeah.
how does the attacker create the same exact thing with the same instead?
They are able to build it, and actually generating number is not difficult because even Microsoft is generating numbers.
Yeah,
right?
but like he cannot predict what number is going to come in
he's
the
not going to
original
predict.
one, right?
So he's going to see the number, and based on that, he's going to present a similar number on the screen.
Similar number.
Yeah.
Same number.
Yeah, but like I'm
So
asking
He
like.
has this two websites open,
Yeah, I know that.
and it just gives you whatever is on. the
It's
actual
not
one.
predicting. Let me put it this way. It's not a prediction. Based on what the attacker sees, similar number is injected. And this is done all through automation. It's not something the attacker is doing manually on the website code, no. So on the genuine website, it detects the number and it's going to prompt the same number. So the user is going to match the number.
Just make the website a little bit slower than the actual number is generated.
So the summary is, so I'm just trying to summarize. So we need protection from social engineering, and we need two things, which is a problem. One is we need to prove that the user is present there actually. Okay, this is one, and in close proximity. And the second thing is we need to verify that the device is close by. So when you're approving, you are accessing a website and you're approving. Like for example, if I'm approving something on my laptop, I need to be close by. Okay, like in this room, I need to be there. If I'm able to do that, then this problem will be solved. Okay. Now I'm going to talk a little bit more on passkey. But before that, I want to give you an overview of the different passwordless options we have. We have Windows Hello for Business. This is our go-to solution for your laptop-based logged on or desktop-based log on. So you are able to log in using your biometrics, like your facial recognition, your fingerprint, or you can even use PIN. Okay.
Sorry, I have a question. I think Windows Hello only work with Surface products.
No, it was.
Because I have other laptops, for example. I tried, it did not work. I don't know, like Dell.
So for the facial recognition, so there are a couple of requirements for Windows Hello. One is because it stores certificate in your kernel, TPM. So TPM 2.0, which is a kernel thing, it's a requirement. Most of the modern laptops should have it. This is requirement number one. Second, for doing facial recognition, it has some camera sensor requirement. So as long as we have these two requirements, if Lenovo, Asus, doesn't matter, Surface, Windows Hello can work across devices. Yeah, doesn't work with Mac, but any hardware which has Windows on it, this is something which is going to work. The second passwordless offering is Microsoft Authenticator. Then extension of that is Passkey, which is FIDO2, and then we have certificate-based authentication. Now, I'm going to specifically talk about Passkeys for the next part of the presentation. Okay. So now Passkey is the next step, and this is coming from the FIDO Alliance, Fast Identity Online Alliance. These are designed to replace password and protect you against phishing. How it works, this is something which we will understand in the next couple of slides. So first of all, let's try to understand how passkeys are built. So passkeys, so whenever you initiate a passkey transaction, it uses PKI. This means your device creates two keys, a private key and a public key. Okay. Now, I'm going to explain this in more detail in the upcoming slides, but just to give you an overview, this private key never leaves the device, which is your authenticator, your mobile device. It would never leave the device, and it is used to unlock the authenticator through a gesture. How does that work? I'll also cover that. But the point is, private key never leaves the device, public key leaves the device. Okay? Public key is even shared with the application. Okay? Even if the application gets compromised, like we see so many times nowadays, it only compromises the public key, which is not going to affect me. Right? Now, as I said, I'm going to explain this exactly how it works in a little bit more detail. But in other words, passkeys are really just passwordless FIDO2 credentials. So this is why we call it passkeys, to make it easy. but the actual technical term will be FIDO2 passwordless credential. Okay, so we don't want to confuse names and differentiate it. But now, let me try to make you understand a little bit on how this works. Okay, so as you can see on the screen, I have a relying party. So you can assume this site to be something like login.microsoft.com. Okay, I'm just going to draw something. So let's say this is ms.com. Okay, relying party is like an application, okay, or an identity provider. So there can be two types for a relying party. Browser is usually called a client. So basically, this is like, it can be any browser, doesn't matter. Of course, as an organization, you would have restrictions, what kind of browsers you want to use, but generally, let's assume any browser. An authenticator is a device, which is generally your mobile device. And as I explained, your mobile device is holding two keys, okay? So it is holding a private key. Okay. So this is holding two keys, even though this doesn't look as key, but yeah. So this is a private key, and then it is also holding a public key. So it is also holding a public key. So this is public. Now what happens is the public key is shared with the relying party. So this is something which is given to the site, public key. But the private key is something which is not shared. So just try to understand that. So in my authenticator, basically, public key is shared, private key is not shared. So I am just going to write the keys one more time. So this is public key, and I also have a private key. So private key never leaves the device, okay? And public key is shared. Now, public key is with the relying party also. Now, what happens here is, each IDP is going to get a unique passkey. So if I register passkey on a site, I give that site my public key, which is exactly what has happened here, right? On the left with the relying party, you can see that the public key is shared. Now, when you are logging in with passkey, the first step which happens is, from your browser, you're saying that, you know what, I want to attempt a sign-in. So this is the first step, right? Any application when you're trying to access, this is the first step which happens. And in this case, the site is going to send back to you on the browser a random challenge, okay, which we call it as nonce. And this is unique and it can only be used once. So the reason why it is secure is because it prevents replay attacks, because this nonce can only be used once. So once you give it to the device and once it is used, it can't be used for the second time. Now this nonce is shared with the authenticator as is, okay? So this is the nonce which I'm sharing with the authenticator. Now my authenticator is going to respond to it. And the way this responds to this is it sends the nonce, but this is going to encrypt this with the public key. Sorry, this is going to encrypt this with the private key. Okay? Encryption is happening with the help of private key. This is now going to go to the relying party. The relying party has access to the private key, sorry, public key. It's going to decrypt it. Private, with its public key, it will be able to decrypt the message, because private and public key is like a mathematical combination. This is something which is making it secure. Once it decrypts it, it's going to issue the token. Okay? And or it might have another process which it might follow. But what I'm trying to establish is we are using asymmetric key encryption, PKI encryption, for this combination. Now, there are few things which it's doing other than that also, okay? Now, when it is signing, the authenticator is signing, it is verifying two things. One is, it is near the client. So how does it verify it? If you're using cross-device authentication, let's say I'm using laptop and an authenticator on my phone, it's going to use Bluetooth. So I would need Bluetooth to be enabled both on my laptop and on my phone. If Bluetooth is not enabled, then it will not be able to check. If it's the same device passkey, then it doesn't need Bluetooth. But different device, it's going to need Bluetooth. Obviously, the other way would be if you're using a USB key, like a UB key or something like that, then obviously it's going to use that key you are going to physically insert it, right? But otherwise, if you're not using that, if you're using Microsoft Authenticator, then you're going to use Bluetooth for communication. Bluetooth has a radius of, I think, 5 meters, similar to this room probably, or maybe less. It is going to verify through the proximity that when user is trying to access it, it's genuinely accessing it. So this way, it's verifying near the laptop, right? So the problem which I talked about, this is solved. One problem is solved, right? There is another problem, and I'll tell you how it solves the other problem. But the proximity issue, wherein there was a MFA fatigue, wherein user was trying to MFA to something else, this will not work. Even if it gets a MFA prompt, it will not work now. With your fingerprint also, it will not work when the attacker is trying to sign in. Okay? Now, this is the real promise of Passkey. Every login is a technical exchange. It's almost like a ceremony. Yeah, you have a question? Yes.
There's another slide. We talked about signing in using Passkey.
Yeah.
It's a question here for initiating the Passkey, and I think it's not generated by default. If I did login by multi-factor authenticator or by basic authentication or whatever, I need to log in or I need to authenticate myself, then I create and initiate the Passkey. Can we do it here in this?
Yes. So, and actually I have a demo to show you, specifically this scenario as to how exactly we generate and how it is secure. But I will just show it to you also, like just answer you and then we'll see the demo. So what happens is, if it's the first time registration, you will be MFA'd and then you will be asked to scan a QR code. When you scan the QR code, it's going to verify proximity, again, through Bluetooth, right? So when Passkey is getting generated also, it's verifying. It's not like it's not verifying. Like the attacker is able to generate Passkey, no. It's verifying the user is present in close proximity through that. I have a demo specifically for this scenario, which I'm going to cover.
Your Bluetooth on for that.
Yeah, cross device, you will need Bluetooth on. Let's say you're accessing an app from your phone and your authenticator is also on the phone, then you don't need Bluetooth. But cross device, like some application on laptop and you want to access it, then you're going to need. Okay?
You have to connect to the Bluetooth or just turn it on?
No. So I think so there's a technology in Bluetooth which is called, I don't remember the exact term, but you don't have to be connected to each other. So what we do is, with a lot of organizations, this is a concern actually, because you can't have Bluetooth on forever. So we only allow certain grids of Bluetooth, okay, to be able to discover. So you're not connecting. It's not like you're paired with a device. No, it's just for discovery, that this is in close proximity and it uses some technology. I'm forgetting the name, but that's what it uses to verify that your device is in close proximity.
Nearby. Like
Nearby.
Yeah, similar to that, but there is, so it is not process consuming a lot. I'm forgetting the term. It's like soft reach or something like that. That's what it is called.
But how does it verify, like MAC address or something else?
Yeah. So it uses combination Bluetooth from your laptop as well as your phone to verify the proximity.
But what are the keys in the Bluetooth and the device?
Keys are on your phone.
I'm asking, how does the laptop verifies this is the correct mobile?
Yes. So it uses a technology called as CTAP, Client to Authenticator Protocol, that helps in verifying this kind of exchange.
Bluetooth is real.
Yes, in close proximity and the protocol. So see, I'm going to explain CTAP also, wherein we are going to break down Bluetooth to device and device to browser, a browser to application, this kind of communication. So browser to authenticator, it uses CTAP. Browser to relying party, it uses WebAuthn for verification. But I'm going to explain it in a little bit more detail in a couple of slides. Okay, so what I'm trying to say is, so this gesture is powerful. So it proves the intent that it's the user saying, yes, I want to log in right now. And then comes the cryptography, which is signing verifications, which happens silently. The reason why this is great is because this does not trouble the user, right? Remember I told you FIDO1 and even FIDO2, you have to carry physical devices, and it's kind of cumbersome, right? That you have to carry them. So with this, we are kind of avoiding something like that. So we are not carrying any device at the same time, and it's not troubling the user. If at all, it's making life easier for the user, okay? So, yeah. Now, talking about the authentication protocol. So when you log in between your browser and the website runs over HTTPS. So the traffic is encrypted, but the real magic which is happening is something called as WebAuthn. It's web authentication. So imagine WebAuthn like a translator. It's the standard API that your browser uses to talk to authenticator, whether that's your phone, your security key, or Windows Hello. It makes sure that the process is safe, consistent, and it works across. Now, the second problem which I spoke about was relying party ID, right? So we discussed that Passkey is maintaining this close proximity, which is helping in ensuring that MFA fatigue is not happening, or we are not entering MFA for the attacker. But the other problem is the user getting a fake website or an attacker built website. This is something which is solved by something called as relying party ID, RPID. So when you build a passkey and it saves the key prompt only comes up if it matches the RPID. So the URL is not going to match. If the URL doesn't match, you will not be able to do RPID at all, because based on RPID only the passkey understands. In other words, if I tell you,
What is the verification is the URL doing?
so it generates a relying party ID, which is in the WebAuthn. So it has to ensure that it's the same URL, otherwise passkey doesn't work at all. So login.microsoft.com and login.microsoft with an apostrophe, this is not going to work. Okay, so this solves another major problem, which is it only works with the exact signed domain it was created. So if you have a fake site, this is something which is not going to work. So you don't have to notice it. The user doesn't have to be aware. If they don't match, it just simply refuses to continue. So this is a major improvement over passwords, over OTPs, over authenticator, because this check was not done previously. So we are kind of giving it back to the protocol itself to enforce the rule, to essentially reduce the human error, right? Because there's always chance of human error here. Okay, I'm just going to wait to see if there's any questions before I move to the next slide. So earlier I talked about the communication between the client, which is your browser, and your authenticator. Okay, so there are three things you can see here: authenticator, client, and relying party. Between your client and relying party, we are using web authentication. And between your client and your external authenticator, like Microsoft Entra authenticator, it uses CTAP, client to authentication protocol. Okay, CTAP is the language your authenticator uses to talk to your browser or computer. Okay, for example, if you plug in a USB key, CTAP is the protocol that makes sure that computer and the key are talking securely. If you're using Bluetooth, for that matter, which we were discussing, or NFC, CTAP ensures that the communication is both safe and limited to the close range. So it can't be hijacked from far away. And when you put this together with WebAuthn, as I said, WebAuthn basically manages the communication between your browser and your relying party or website. This is something which gives you the complete 502 standard. WebAuthn covers browser to site, and CTAP is covering browser to authenticator.
Could you please explain what the CTAP does?
So CTAP is responsible for the authenticator to browser communication. So ensuring that these devices, so communication of these two, ensuring that these devices are in close proximity, no matter what platform you're using. If you're using a USB key or if you're using Bluetooth, so this is something which the CTAP is going to do.
How does it work? How does it communicate?
I don't know. So there is a Bluetooth technology which it works. I'll have to. Actually, I have it handy. Hopefully, I will be able to tell you probably during the break time. I will tell you the technology which it uses for that kind of communication. Yeah. All right. Now, let's try and jump in trying to understand passkeys in the Microsoft provided in the mobile device. It works with iOS 17 plus and Android 14 plus. Now, one thing which I think a lot of customers have complained from Microsoft is that every new feature which comes in, it comes in with a cost. So this is not coming in with any additional cost for you. So this is something which is inbuilt. It doesn't matter. Of course, with Entra ID P1, P2, you get more and more benefits to be able to use this technology better, but this doesn't come in with any additional licensing cost. So you don't need a license for passkeys or anything like that. Okay. Now, there are three options of enrollment. Okay, and I'm going to show you demo of all these three options. The first option is signing into the Authenticator app on the mobile device and setting up passkey. This is the best user experience. It's no longer in public preview. This was probably a month back slide, but this is something which is available. WebAuthn registration initiated from the same device as Authenticator. And the third is WebAuthn registration initiated from a different device, so laptop and your phone. So this is something which I think someone asked a question, so I will show it to you as well. The other thing is, right now for Microsoft Entra, we are storing passkeys locally. Okay, we are not synchronizing it with your Entra user account or anything like that. We are storing it locally on the device itself. With our Outlook or let's say Microsoft personal accounts, we allow you to sync it. So you can sync it with Google, you can sync it with iOS. This is something which we are allowing. Right now, we are not allowing you to sync it with Entra. Okay. This is something which is expected to change in the future, that we might allow synchronization of passkeys with Entra, because now what happens is if you change your mobile device, your passkeys don't travel. You have to set it up again. So this is something which might change. Some might argue that they don't need that because this is something which is making devices more secure, and I won't argue if someone says that. Now, let's look at same device registration process, okay, for passkeys. This is something which is inside the Authenticator app, okay. As I said earlier, this is the smoothest way to register through the Authenticator app itself. This is the recommended flow because the app kind of guides you as to what exactly you want to do. So it's self-service. You don't have to teach users anything. It just works. So basically, when you first open the app, you will get through some initial setup screens, including data consent. Then you'll be asked what type of account you want to use. So you choose your work or school account, whatever. And for sign-in, you can use your permitted MFA methods. In this example, we are using a temporary passcode. And in this case, you can use passkeys and MFA push notification both. So now, as I said, the app just lets you walk through the requirement. So this is something which is all done through the app itself. As passkey provider, at the end of the process, you are ready, and this is what it shows, that the passkey is created. And yeah, and if you click on here, you will get a short explanation as to what exactly this is. And that's it. So this is something which you have set up your passkey for Entra ID. Okay, we push this. Okay, so you can push this experience through multiple ways. We can push this through Intune or some other mechanisms as well, conditional access and things like that as well. Now that you have registered passkey, this is the process as to how the sign-in experience works, right? Now, in this example, this user is trying to sign in, and this is on the same mobile device. So this is the sign-in experience you're getting. So basically, there's an attempt. There you entered the username. There is no password prompt. It asked you for passkey, and that's it. So at this point, you simply confirm with your face, your fingerprints, or your PIN, and once you do that, you're signed in. Okay. Yeah.
In this case, the website did save the public key for this user account.
Yes.
It should.
Yeah. So public key is saved with the website. Yes.
So this login mechanism, this can be utilized as a SSO as well to with my custom build applications.
Exactly. So this is actually double SSO. So seamless single sign-on, right? So SSO is when you have same credentials, but seamless is when you are putting in less efforts, or you're just able to log in. So in a lot of ways, you can call this as seamless SSO as well.
So the response part will be same. Like currently the SSO which we are using with the Microsoft Entra ID,
yeah,
as a response we are getting a token.
Yeah.
So response method will be same.
Actually, with this, we are not changing the underlying mechanism. So if you're using OAuth, you're getting a refresh token or whatever tokens you're getting, we are not changing that. We are changing the way you are going to achieve the token. So this doesn't changes anything else. Like when we say with Windows Hello for Business, when we use Windows Hello for Business in the environment, we are not changing Kerberos, right? Kerberos remains. We are just changing how you present your credentials. You were presenting credentials in terms of password. Now you're presenting credentials by key, okay, which is securely stored in case of Windows Hello for Business in the TPM, and in this case using Authenticator on your mobile devices.
Last question on this. So I'm being NPC. Okay, I have one application which is accessed by Ministry of Foreign Affairs as well. Okay, and this is on my own network. Okay, so I have allowed them to access my application and added them as a guest user in my Entra ID.
Yeah.
So in this case, if they are not using this passkey, so their authentication will be done as it is, the way they are doing, and rest of the things will work seamless, right?
Yes, exactly. So this is not going to affect them. They can choose to use passkeys also in your tenant as well. So this is fine too.
Thank you.
I have a question.
Yeah.
So in case I'm trying to enter the same website just from another device, let's say a laptop or another device.
Yeah.
So when I enter the password, it should promote me on the device. And then
Yes. And I'm going to show you a demo of that. So there's, I think it's the next demo only, wherein I'm going to show you the cross. No, I think it's a demo, the third demo. So I'm going to cover the specific scenario. So
You can have like several passkeys for the same website in different devices.
yeah, you can.
I can have one passkey for mobile, another passkey for laptop.
Passkeys are unique. So
I know.
Yeah, you can have.
But the website now will have like several public keys for me for the same account.
Correct, it will. Okay. Yes. So you will have multiple public keys for the same user account. Yes, you will have that. Okay. I'll take one more question if there is any. Otherwise, I'll move to the next demo. Okay, I'm going to move to the demo. Now, this is the WebAuthn registration on the website as well itself. Now here you can see that you're going into the security info and then you're clicking on add. It's asking you to add a passkey for more secure sign-in. You can click on next and it will say which device you want to use. You can choose the device and then it is going to ask you to continue and do next. This is just the screen. And here, it's going, you will have an option to choose iPad, iPhone, or Android device. Next, it's going to prompt you for your QR code. So here's where it gets interesting, So this is where cross-device authentication. So let's say your passkey is on your phone, but you want to log in into a site on your laptop. So on your laptop browser, it shows the QR code. You scan it with the phone. Bluetooth proves that the phone is close by to the laptop. And after that, the rest of the communication is happening over HTTPS. So however, in this case, it's not the sign-in, it's the registration. So here it's going to register. Then it's going to ask where I need to save the passkey to. So this is something which you will choose to be authenticator. And once you are done with that, then it's done. So basically, you have saved your passkey on the and you are able to log in. So this is another way of registering. So in the first instance, you use your mobile device. Now you use Microsoft aka.mfa setup or security info for doing the passkey registration. And if I show you a quick demo as to how the authentication is going to happen after that. So let's see now. So here, again, see the good thing with this is, basically, now when you're going to try and sign in, it is asking you for it's going to ask you for a username. You enter your username and then it's going to ask you for a, this is the scan which it's going to ask you. You use your mobile device to scan it. You approve it on your mobile device, and that's it. You get authenticated. So you can understand the way it's working. So basically, it's using your phone and your laptop, and it's confirming close proximity using CTAP protocol through Bluetooth to support you to sign in here. Okay? So you had a question. I don't know if that answers it or... Yeah. Okay. Now, this is another example. In this example, I'm going to show you how you can register using a third-party key, like a UB key or a security key. So if you want to register it with passkey, how does that work? So in this case, I would obviously need a physical device. Okay, and I'm giving an example of UB key. There are many other vendors as well with this. It's not very expensive. Right now at Microsoft also, for some people who access some sensitive data, we are not allowed to access it using our Microsoft account. We need to order a specific UB key for able to access it. So some of our internal content, you can't access it with even our Microsoft account. So we are doing that as well. Now this is a process of security key registration. So in this is your Windows machine. Now what you're doing is, basically you are going to, it will give you a prompt to add the key, and then you're going to insert the USB stick. And yes, then it's going to ask you and make sure that it's you. And then you set up the security key. In this case, it will ask for the first time when you're logging in, it's going to ask you to for the PIN, okay? And that's it. So your security key registration is done. So basically, the next time you log in, of course, you're going to need the physical key, and using that physical key, you will be able to log in, okay? So, this is FIDO2. And this is pretty similar to how your, like 10 years back, we used to use smart cards, right? So this is kind of similar to that technology wherein we need physical device. Some devices have extra layer of protection wherein they just don't need the device. You can enter PIN or you can enter some small fingerprint reader on the device itself, and then it is able to authenticate, and you don't have to enter the PIN. Someone asked me before I move forward, like how can PIN is secure? Right, in this kind of situation, especially with security key, and even in situation with Windows Hello. So the reason why we are okay with pins in general is because, so imagine like your ATM cards, right? So when you have an ATM card, you go to the ATM and then you put, now you have cardless transactions as well, but just imagine that you're putting in the card in the ATM, you have to enter the PIN. So the two factor is physically inserting the card. So card is one and then the PIN is second. So PIN is attached to the card, okay? Without card, even if I know the PIN, it's not going to be useful. The same concept applies with these security keys. So I need to have physical key to be able to use the PIN. Same thing applies with Windows Hello for Business. The PIN is attached to my laptop. So someone has to steal my laptop, and because the PIN is localized, you can't use the same PIN on another device. So that is something which makes it secure. Okay?
I just have one question. So now if I have registered the security key and I have registered the one in the mobile, let's say, when I'm trying to sign in again, it's like I need to reconfigure like which method to choose, or it will show to me.
No, it's going to show you options. It's going to show you all the options.
And I need to choose which one of them.
You need to choose. So so if you have the security key inserted in the login prompt, it will show you that. Sometimes I've seen now, when you have to do cross-device authentication through Authenticator, it just takes a while and it's in the drop-down. So we have 3-4 options. Yeah. So you just have to scroll down, choose phone or device, and then you can use.
So it's not like the one which is registered last.
No. I mean, generally, so I might be wrong here, but generally what happens is Windows understand what you're using regularly, and then it just brings that option on top always. But yeah, so I think that's how it is going to help you choose.
So you said that the private key is saves in the device.
Yeah.
So like for example, you have 2 phone or 3 phone.
Yeah.
And all of them have same account. Is the private key gonna be the same?
Different. So passkeys are always unique. Unique to the device, unique to the account, and unique to the site. So for example, if you have a Microsoft account on this site, so it's unique, but your device is different, so it's going to create a new key. So if you have 2 devices, I also have 2 phones which I use. So on both the phones, I will have different passkeys. Right now, for enterprises, we don't have a feature to sync the keys like Google has, right? Even Microsoft, for end users, we are giving ability to sync keys. But for enterprises, for your Entra ID, we are not giving this option right now. But I have heard from the product group that this is something they are working upon. Okay, so I don't know if it will come or not, but this is something which, because there's a lot of request for synchronization of keys. Okay, I'll take one more questions and then I'll move on to sharing the security, sign in with the security key demo. Yeah.
Earlier on the demo WebAuthn registration, after the sign-in process, after the security, where was I going to progress? Like, would I be able to progress on the PC or on the phone?
So, it depends on where you want to, right? So your authentication will start from where you want to. Like for example, if you're accessing your application from your laptop and you're doing cross-device authentication, you'll continue on your laptop. So your phone is only going to use to make sure, how do I say, like close proximity and provide you with authentication, but you will continue to work on your laptop. Yeah, and you might choose to start from your phone and then you can continue on the phone. So it's your choice. Okay. All right. So again, a similar experience when you try to sign in with the security key as well, right? So let me show you. So in this case, you can see just that you're trying to log into the application, and this is what I was talking about. Sometimes the option takes some time to come. And then you will choose the security key, right? And once you log in with the security key, it will prompt you for PIN. Certain third-party security keys, they also have an option to do fingerprint or something like that. So this is something which you can use as well. Okay. So 3 scenarios. Excuse me. 3 scenarios: registering from phone directly, registering from the website, by so cross device, and third is using some security key. Okay. Now Yeah, so these are just some of the options. Now let's talk about, and this is something which someone asked, do I just have one passkey for everything? The answer is no. Each site and each account gets its own passkey. For example, if you have a Gmail account, it has its own passkey. Your Microsoft account has a separate passkey. And if you have multiple accounts on the same site, each account would still have its own passkey. This separation is actually very good. It means there's no single master key if it's stolen. So, and that could open all your accounts. Instead, each passkey is unique for each site and account. So if one site is compromised, it doesn't affect your others. Your passkey for Gmail can't be used for Microsoft, and your Microsoft passkey can't be used for Gmail, right? And I think this is the main improvement when it comes to passkeys. So over passwords, where the main problem was people would reuse password. In situation of compromise also, data leaks, passwords are compromised, then your entire thing gets compromised. Some user in the organization does something bad and shares the password through social engineering. Like, I was watching this video on LinkedIn the other day when there was someone interviewing and asking about their birth date and kid's name, and a lot of times we tend to use those as passwords, and they were able to crack, and they were showing this live as to how social engineering can impact something like this. Okay, now let's talk about authenticators and the passkeys which they hold. So there are authenticators can be first party, like Apple's iKeychain, okay, or iCloud keychain, Android's password manager, or Windows Hello. They are built into the platform. So Windows Hello is of course for the laptops. iCloud keychain is for the Apple and things like that. Or there can be third party, like Microsoft Authenticator and others. These are third party authenticator which sit on top of your device. Okay. Now, the passkeys are of two types. First are device-bound passkeys. These are tied to a single device, usually stored in secure hardware like a TPM or secure enclave on your phone. They are kind of secure because they never leave that device. But if you lose the device, you also lose the passkey. So you'll need the recovery steps. Usually enterprises, organizations like this option. So they don't want to save the key because it gives them better control. For example, if an employee loses the phone, then what we do is we issue something called as temporary access passcode. So in today's world, as a user, you will never see password, because when the user signs in for the first time, even if they forget and they have to use password, the admin gives them a temp passcode. They log in with that, and then they start using passwordless options, which is Authenticator or Windows Hello for Business. Yeah, and as I explained earlier, device bound is more enterprise focused, Syncs is more consumer focused. At Microsoft, for the Microsoft accounts, client accounts, we are also allowing you to synchronize the passkeys. Now, where can they be used? They can be used on websites, any modern sites that support passkeys, applications. Most apps and browsers are supporting passkeys. Windows operating system manages passkeys available to all browsers. Other platforms, WebAuthn function, cross-platform, which works across device and its ecosystem. Now, I'm going to summarize what we have discussed. Okay, so the thing which we have done is protection from phishing. So these are some of the key benefits of passkeys. Protection from phishing. Browser checks the real domain. Fake sites can't be tricked. So as I said, the RPID match. So users can be tricked by lookalike websites with passkeys. Here, the browser itself checks the website identity. If it doesn't match exactly, the passkeys won't work. So the system is kind of protecting you automatically. You're not relying on users' ability or knowledge, because we know Not every user is IT aware. This is something, and having said that, it's not like just the IT aware users get phished. Like I'll tell you, I got phished once, being a Microsoft employee. So I had to do a simple thing. I was working with some customer in doing their PKI migration from SHA-1 to SHA-2. And a couple of years back, I had used a presentation, right, to present it. Now, obviously, generally what we do is after the presentation, we share it in a PDF format, not in the PPT format. So I shared it with them. I could not find my original PPT. So what I did is I went online. On the first page results only, as far as I remember, I tried to do a PDF to PPT conversion. I downloaded the file and my machine got attacked. Okay. So I received a message or email or something like that my machine is compromised. So I need to format my machine and disconnect it from the network. So you can understand, right? It is sometimes even IT aware people could get phished. So the reason for that phishing was I should have used an approved tool for doing that. I should have verified if the website is genuine. Maybe the website was ranked through Google search or something like that, and it was not a good website. The file download triggered the attack on the machine. So yeah, the other thing which we spoke about is stolen credentials. So we have all heard about this, right? There were many public cases as well, right? Wherein a database of username and passwords were leaked. And I think in your iPhone and Android also there's a function wherein it says that this password was leaked in some breach or something like that. This is something which is going to be not a problem, right? Because you are not going to store passwords on any public websites. So you will be using passkeys going forward. Like presently, I'm pretty much using passkeys across, right? For my Google, for Microsoft, for Facebook, pretty much everywhere I'm using passkeys. The thing with no stolen credentials is because there's no password and the key is stored on my device, right? It's stored securely and it is never, you can't take the key out, at least right now, okay? There are talks of syncing it, but right now for enterprises, you can't even take the key out. It's similar to your hardware security modules. So basically it prevents you against stolen credentials, safety from remote tricks. So attackers often call users pretending to be IT. This is the same example which we talked about, adversary in the middle attack, wherein there was a MFA fatigue and things like that. This is something which can be prevented, right? So no more entering code, no more approving for logon. We are using passkeys. And passkeys won't pop up because of the first point. So, and again, we are checking for device proximity using CTAP. So this is something which is going to help us as well. Fourth is the user experience. Now, one of the things which I always say is, so there is a graph. I don't have the graph handy, but security and easiness, right? When security comes with difficulty, it's always difficult to adopt it, right? This is one reason why a lot of organizations adopted Windows Hello for Business, because Windows Hello for Business made life easier, right? So at Microsoft, I don't remember my password, okay? I don't remember when was the last time I used my password also. I never reset my password as well, because I never use it. I don't even know if I have a password, to be honest. Because I'm in an ecosystem wherein my setup is automated through MFA. I'm using passkeys, Windows Hello for Business, so I'm not even seeing password. Forget about using password. So, and to be frank, I feel much better to not use password, right? I feel much better to use my facial recognition because it's easier, at the same time it works. Having said that, for your organization, it's not something which you just go directly. We call it, from a passwordless perspective, there are 4 phases. First phase is where you deploy the offerings. So hypothetically, in your organizations, you deploy passkeys, Windows Hello for Business, Authenticator, these offerings. So you are kind of enabling organization to adopt this. Second phase is where you reduce the password visible surface area, okay? So first phase is done when you have these offerings available. Second phase, you reduce the password visible surface area. Third phase is where the users never use passwords. And fourth phase is when you eliminate the password. So this is kind of a journey. It's not a one-step thing. Yeah, as I said, it's better from an experience perspective. Strong security. So finally, the reason why we say strong security is because Passkeys live in a secure hardware inside your phone, PC, or USB key. They are tamper resistant and built in as MFA by default. Something you have your you have like your biometric or PIN. So yeah. So basically, in real life, the benefits are clear: no phishing, no stolen credentials, no remote scams, no password pain at all, and all of this backed with strong cryptography. Yeah. So we have 17 more minutes. I'm happy to take if there's any questions. But yeah, that's pretty much what I wanted to share. And I had one more thing to share. Okay, let me do that. Okay, just on the portal, I want to show you one more thing. Okay. Okay. So, yeah.
Question. Pizza also arrived.
I'm sorry?
Pizza is also arrived.
Yes.
So I will go downstairs to pick them up.
Okay.
So I will give you 5-10 more minutes. Okay. Then you will ask the questions and I will finish. The streaming is still going on, don't forget, okay?
All right.
I will close the picture.
Perfect. So we talked about authentication strength. Let me take you through the policies as well and how to configure passwordless essentially in your environment. So here you can see these are different authentication method policies, and I'm going to specifically go into Passkeys. And this is something you can enable. You can enable it for specific users or you can enable it for all users. So this is a choice which you have. And these are some of the options, right? Like allow self-service setup, enforce attestation, enforce key registration, register specific keys. So here you can, I told about Bluetooth and GUIDs being allowed. This is something which we can add here. So specific devices will only be allowed for the Bluetooth functionality. So these are the AA GUIDs which I was talking about. So you can restrict what kind of devices would be allowed from an organization perspective. So you can enter Microsoft Authenticator, and if you have something more to be added as well, this is something you can add. Also, from an authenticator perspective, you would be able to do it. Generally, what I recommend is to go based on groups. You don't want to do it all together. So you take based on groups. You have a pilot of 10, 50, whatever users, and then you kind of expand from there. Okay.
You mean to do testing first?
Yes.
Group.
Correct.
Yeah.
So ideally testing first with a smaller group and then expanding it with more and more users. Similar to how we transition into the Entra ID authentication also. So same way you can choose it.
I would like to apply something like that in my organization, but actually, so what's the best practice? So if I need to have some kind of guide, I know that there are a lot of resources available online. So if I need a resource to know what's the best practice, a guide to follow, actually, where we can find.
So I don't know if you have some relationship with Microsoft. You do, right? So generally, if you reach out to the CSAM, we have structured delivery for something like this. So basically, prerequisites, what is going to be your design, how are you going to go about it, what are some of the prerequisites and things like that. So this is something which is all covered as the part of the delivery. Okay. Yeah. So we have something called as intellectual properties, which is a structured way of delivery, which is built internally for our customers only. So this is something which we can help on with.
Okay. We have, for example, Power Apps we create for our clients, and these Power Apps are connected to Microsoft Dynamics.
Okay.
So because of we have multiple clients, so everyone has their user to Power Apps. For example, maybe 10 clients, for example.
Yeah.
Okay, but actually the connection to Microsoft Dynamics, because of their user cost is expensive in Dynamics.
Yeah.
So we made only the connection to Dynamics as one user. So all 10 clients
using one user.
One user.
Okay.
So inside the Power Apps, so we made the connection to connect with one user.
Okay.
So the problem is that if password change it,
Yeah.
so that's connection between Power App and Dynamics disconnect. Okay.
Yeah.
So I would like to apply, for example, this authentication, but I'm afraid that if I apply this MFA, will it break it?
It will not break it. It will make your authentication difficult, right? You will need Passkeys registration on 10 different devices because they are all sharing passwords, right?
Yes.
And actually, this is the worst thing you can do in an
Yeah, I'm an accountant, so don't.
which makes it even more problematic because see, the fundamental problem with password sharing is like you have it shared with 10 people whom you're going to catch if it is shared with some.
No, I'm not sharing it actually. So the point is that in the back end Power Automate, so we connected Power Apps with Dynamics with Power Automate.
Okay.
So I'm the one who only have access to Power Automate.
And the user are using their own credentials.
Yes, I'm not sharing it with them.
Yeah. Then you can still use it. It's not going to break it because you are going to register passkeys for the users, right?
Yeah.
So it's not going to.
But actually the point is the most problem is that the connector between Power Apps and Dynamics is Power Automate. Okay, so in Power Automate, I made only the connection is using only one user.
User account.
Yeah, so I have a problem with if this user, for example, change the password.
Yeah.
So I have to do reconnection again for all
the users.
Yeah, and they are not 10 clients, they are more.
Yeah.
Okay.
Yeah.
So I have to test it out with another.
So I can't imagine how it's working, but but yeah, this is something which is to be checked. Yes, definitely.
I have a question. If you use Azure, Microsoft Azure, when you log in or when you use an application, do they have an authentication?
Yes, of course.
Because like recently I've discovered that the credentials are saved in a app setting JSON file, which is publicly available one when you do a network scan.
Okay.
So would that be good or bad?
It's bad because
I know it's bad. So is there authentication like?
No.
I know. I think that you have heard about it.
Yeah. So see, we don't recommend that. What we recommend in this kind of situation is we recommend managed service account, wherein you're not saving your credentials anyways in JSON, right? It's only the user details.
No, it is saving like the client secret and client ID.
No, we don't recommend that. So what we would recommend, so this is outside this topic because Passkey is not for that. Okay.
Yeah, I know. I'm just asking about the authentications.
Yeah. So in that case, you can leverage Key Vault for that. So you save your keys in Key Vault, and then you're leveraging
a different subscription.
No, yeah, it's a different technology within Azure. Yeah.
But it's a different subscription.
It's used to share secret. It is used to save secrets.
Yeah, but it's still a different subscription, right?
It can be in the same Azure subscription also.
Really?
Yeah. It's just a small thing. Yeah.
It don't cost anything. So good thing is that whatever you have said in the Key Vault, there's a one-line command and one function is available in the Azure. Just give the Key Vault name and add them directly into the environment variables inside that service.
But when you're doing a quick session or quick application accessing, the credentials are saved in the app setting JSON file.
See,
so it is a bit.
There are two things. One is app setting JSON file, right?
Yeah.
One is you have environment variables. Okay, so you can directly.
Sorry to interrupt, but let's maybe take it over the snacks. Okay, I don't know. I'll take one more question if there is any. Otherwise, I have 3 questions for you guys for the giveaways. Okay.
So for this Authenticator app, so I've seen that you have option to add additional AGU ID, right?
Correct.
So is it enabled with the Google Authenticator as well? Or vice versa? Google can be authenticated through Microsoft Authenticator?
No. So you can use Google Authenticator to save your like Microsoft Online keys, but not our Entra keys. No. Yeah.
So the Passkeys are not.
No, you can't save it on Google Authenticator. Okay. All right. So I have a small giveaway. Thank you, Fateh, for that.